Guys, we are closing down this whole school year. We're up to 11-2-3. Or I should say trimester, because this could be second try, but here we go. We now know what this is. That is a point, which is at the end of the spinner, where this is A and this is B. But it's along the, I should say BI, but anyways, you guys get the idea. We've been working with this. So this is something you may not be familiar with. This is trigonometric form, which is also called polar form. Our book uses this a lot, so just understand that these are interchangeable terms. This right here, right there, is your radius, which ends up being your hypotenuse, which I call the spinner, and it's also now your modulus. So the length of your modulus. So with all that being said, what is that? That is your argument. What is your argument? Well, if I spun my spinner that far, that's my argument. So, how do we get that typically? We find this little slice and subtract it from 180. Alright, I need a sharpened pencil. So alright, there it is. So, we know this. We've been working with it quite a bit. This is the length of your R. This is just your your Pythagorean theorem with an R snuck in there. So it's really c squared equals a squared plus b squared, square roots over both sides, replaced with r. So r is now your spinner, your radius, but it is your hypotenuse. So, not to confuse you, but here we go. Write the complex number, that's what this is, with this, in standard form a plus bi. Just so this pops out at you, that's my r, that's my r. Now, this right here is my argument. That's my argument. I call it, pencils are breaking on me, I call it how far you spin your spinner. So there's my spinner, 210. We've been doing a lot of this, 180 plus 30. And so that's my 30 right there. Now, I'm going to do this twice on this problem, but then I'm not going to do it twice again. So we got our spinner, 210, 210, same picture so far, but here's where I want to make something clear. Some students look at this and they go, hey, R is 8. So they're like, that's the length of my spinner. They're not wrong. But if they use that dimension, then if that's 8, this has to be 4, which is negative. And then this needs to be times the square root of 3, so that's negative 4 square root of 3. Now, it's not negative because that's negative. It's negative because it's that direction. So, with all that being said, I would now find cosine of 210. So I'd have 8 times adjacent over hypotenuse plus I sine, whoops, I'm going to erase that. I'm actually going to find sine of 210. Sine of 210 would be opposite over hypotenuse. That'd be negative 4/8. Now what's this 8 doing? What are these instructions? Leave it in 8 plus bi. Well, that's just saying multiply that through. So these 8s would cancel. I'd end up with negative 4 square root of 3 plus, and then these 8s would cancel, actually minus 4i. And if you think of it, and you look at this picture, you'd think, oh yeah, here's my x, here's my y. So, why am I doing this a second time? Student number 2 is simply going to draw your 30, 60, 90 and go back to what we've been doing. Call that my 1, so that's 2. This is my square root of 3, but that's negative. So we go back to this formula. 8 times cosine of this would be adjacent over hypotenuse. That's negative square root of 3 over 2 plus I times sine of 210, which would be negative 1/2. So if I distributed this here, the 2 goes into the 8 4 times, so I get negative 4 square root of 3. The 2 goes into the 8 4 times that's negative 4i. So I'm saying either way is fine. You're going to get the same. So this, though, does not paint a picture of this. This just helps you get that inside stuff. So this inside stuff doesn't matter what dimensions you use, because you're going to get the same stuff anyways. In other words, negative 4/8 is the same thing as negative 1/2. Negative square root of 3 over 2 is the same thing as this. So different ways. So let's do this one. First thing we're going to do is obey the argument. So it means take your spinner, spin it up 45 degrees. Now I'm going to go like this. Now here's the thing. I'm going to just look at this. I am going to ignore that 5, because that 5 says that this is 5. But what I'm going to do is I'm going to use my 45, 45, 90, and I'm going to use my easy values, figure out what this is. What's cosine of this drawing? Adjacent over hypotenuse plus I times sine of pi over 4, which is opposite over hypotenuse. So 1 over the square root of 2. So if I distribute, I'd get 5 over the square root of 2 plus 5i over the square root of 2. Now, I doubt they're going to leave their answer there, so let's get rid of these square roots. So I get 5 square root of 2 over 2 plus 5i square root of 2 over 2. And there's my a plus bi form. Okay? All right, so let's continue. It says graph each complex number from example 1a and example 1b. Well, we kind of already did here, but let's just act like we didn't. That'd be negative 4 square root of 3, so that'd be, we'll just call it to here. And then down the I-axis, 4. 1, 2, 3, 4. So there it is. That's the point that this represents, but really it's the end of the spinner, but it is just a point. Now how about B? Well, that's here. Well, 5 square root of 2 over 2. I'm just going to make this simple and go 5 square root of 2 over 2. And just know that I have to go up the same amount. 5 square root of 2 over 2 up the I-axis, and that's my point. So I graphed the number, which is just a point. So there's example 2. All right, so this next example is going to go a little bit deeper. Starts out pretty easy. It says graph it. Well, if you think about this, this says go left 3, 1, 2, 3, down 3 square root of 3. Well, if I kind of keep track of these sides and I think about it, this is looking like a 30, 60, 90 because I'd multiply that by the square root of 3 to get here. So now look at it. So I know that's graphing it. That's the point. But really it's the end of the spinner because that's my R. So I'm done with letter A, graphing it. It's right there. Well, I hope I was on there. I didn't look. So left 3, down 3 square root of 3. There's a relationship here that should pop out at you. I had to multiply that by the square root of 3 to get that. So that's telling me this is 60. I'm kind of jumping ahead of the game, but it says write the complex number. So they're saying this is this, in part A in polar or trigonometric form. Remember, that's r cosine theta plus I sine theta. Well, you must know the modulus, which is just simply saying find r. Well, if this is a 30, 60, 90, which it is because these have the relationship, I double that. Now, some of you are like, oh, it's negative 6. No, 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 no. Your spinner's never negative, so there's 6. That's my r. Cosine, what is this? Well, that's how far I spun my spinner. Well, that's 180 plus 60, which is 240, plus I sine 240. Now, I'm okay leaving it here, but your book is pretty insistent on thinking like, okay, pi over 3 is 60. So 60 times 4 is 240, so I got to multiply that by 4. So I'd get 4 pi over 3 plus I sine 4 pi all over 3. And there it is. So the argument is right here. The modulus is right here. All right. Some more of this. Find the trigonometric form. So we're talking about that. And of the complex number where the argument satisfies, and notice this is putting limitations on it. So don't go anywhere between 0 and 360. That's what it's saying. And no negatives. So if I start with my drawing, this is the same thing as 0 minus 2i. That's just like this. 0 down 2. That's where it stops. Well, this is interesting because this is saying you spun your spinner all the way to here. Remember, we got to spin it in a positive direction. That's why I went this way. But I'm like, wait a minute. I need to find out what r is from this. Well, r, my spinner has to be length 2. Just has to be. So there's my 2. Now I need to go cosine. Now how far did I spin this? 270. And then plus I sine 270. And there it is. There it is in trigonometric form. This one. Now when you see that square root of 3 pop up, your brain should be going, wait a minute, they're trying to sneak a 30, 60, 90 on me. I'm going to try to do it over here. We're going to start by plotting the point. So 4 square root of 3. Now just so you know, that's 4 times 1.7, which is like 6.8. So when I go down 4, I shouldn't go down that far, so that it looks proportionate, so that I can recognize this. Look at, that's 30. How do I know that? Because this side is this side times the square root of 3. That makes this 60, that makes that 90, and now we're ready to go. If that side is 4, this has to be 8, which is my r. So I can say, right now, based on this little formula, my r is 8. But now I got to find cosine of my argument. Well, if this is 330, excuse me, if that's 30, this has to be 330 plus I sine 330. And if they are insisting that we use radians, which they might, that'd be 11 pi over 6 plus I sine 11 pi over 6. 11 times 30, essentially. And there you go. Last one. 4 minus 7i. Well, 4 to the right, down 7. Try to make your drawing look a little realistic. So I'm like, okay, well, I got to figure out what this is. There is no 4, 7 blank family, so there's only one way to get this. A squared plus b squared equals my r squared. That's my r. So that's 16 plus 49, which is 65, equals r squared. So we take the square root. So this is the square root of 65. So I'm putting it in trigonometric form. So that'd be the square root of 65. Now here's what, this is going to be a little tricky. I have to figure out what this is, and then subtract it from 360, because really this is my theta as far as like the formula goes, theta. So I'm going to change that into alpha and say, all right, if we find alpha, we subtract it from 180, we'll know our argument. So that's our argument. Here we go. Well, how are we going to do that? Well, we could use sine, cosine, tangent. I'm going to use tangent. So tangent of alpha is opposite over adjacent. Get out my handy dandy calculator. And here we go. Second tangent, -7 divided by 4, enter. -60.25. So that means this is 60.25. That's what this is. I need to subtract that from 360, because this is the argument, how far you spun your spinner to get to that story. So I'm going to go 360 minus 60.25. That should have been easy to do in my head, but so it's 299.75. So this is kind of getting messy up here. So my answer for this would be the square root of 65 cosine of 299.75 plus I sine of 299.75 with the parentheses in there. Weird looking answer, but there you go. Definitely a few of those on your homework, so good luck. If you like the video, like and subscribe. It's all about the hype.